Right, this is the second video of the summer, getting onto A2 statistics. This is, today we're going to look at further hypothesis testing for a mean. So it's carrying on like we did in SS02, where we were looking, and you can have a go at this question, where we were looking at hypothesis tests, and in S2 that was definitely a Z test. So here the difference between what we did in S2 and what we're doing now is that we're going to look at the t distribution. So this question is just an S2 and it's looking at previous surveys. The mean distance was this and the standard deviation was that. Because it's previous surveys, we're taking that as being the true population mean and the true standard deviation, population standard deviation. So this is definitely just a Z test like we did in S2. So please pause it, have a go at it, and then hopefully I'll have the answers. No, I won't. Oh well. So you know what you're doing, so. Right. So, difference now is, just like the previous one, we don't, if the sample size is not large, in other words if it's small, and if our standard deviation is not known, but it is a random sample from a normal distribution, then it is definitely the t-test. If the sample size is very large, and we still don't know the standard deviation, but it's all the rest of it is true, then we will use a Z test. We only use the t-test if it's not large and the standard deviation is not known. But the key thing first of all is, do you know the standard deviation? If you don't, then you need to even consider the t-test. If you do know it, then it's a Z test, so it's not important. This is the key information that you can get from your formula book, which you can download online, AQA formula book, the whole booklet. I would advise you to print it off and highlight relevant parts. Okay, so this is your normal distribution, and then below it will be your t, and it will tell you that it's mt at n-1 degrees of freedom. First question, key elements. It's normally distributed and they've given you the population mean. Please pause it and then we'll have a look. So, for the solution, you should have important fact to note before you even get any further facts to note. Okay, we're testing, it's a population, so we're testing it, and it then ends up as a two-tailed test. Oh, sorry about my spelling, significance. It's a random sample. The weights are from a normal distribution. Standard deviation is unknown and the sample is not large, which tells you that we have to carry out a t-test because the sample is not large and the standard deviation is unknown. It's definitely a t-test rather than a Z test. So it's two-tailed. So this, should have less than or equal. Can't remember the question. Greater than. Critical value, because it's two-tailed, has to go both sides. The degrees of freedom are going to be 7 because there's 8 of them. So we want degrees of freedom 7, and you should come up with that value. Okay. The question wanted a 10% significance level. So a 10% significance level means that you've got, and it's two-tailed, which means you've got 5% on either side, which you've got 90% in the middle, which means on the table you have to look up 95% for T7, which is where you get your plus or minus 1.895. In the table you can only look up the positive value, but because of the symmetry of a normal distribution, you know it's true on the other side if you flip it over, because of course the mean here is 0, so you know that plus or minus is the same. Again, apologises for the spelling errors. Second sample, please pause it, have another go at it, decide whether you think it's mean, it's Z or T. Okay, so let's have a look and see what we think. The 4 key criteria of our important facts are: we're testing whether it's less than, which means it's a one-tailed test, it's a 5% significance level, it's definitely a random sample, it's definitely normally distributed. We don't know the standard deviation and our sample size is not large. It has got to be a t-test. Okay, those 4 facts telling us it's a t-test, unknown. Okay, so our test statistic, this is our critical value. Not test statistics, critical value we have looked up. with our degrees of freedom of 10, because there's 11 items. 10 degrees of freedom with our 5% significant level. If it's 5% significant level and it's one-tailed, we want 5% down here. If we're reading it off the table, we've got to have our 5% up here, but we read it off as a negative rather than a positive because we know it's the other way round. Okay, check your values. Okay. Next one, same thing. Hopefully you should get the hang of this now. Pause it, do it. Key important facts. Testing whether the population diameter is equal to, which means we're also testing that it's not equal to, so it's two-tailed, 5%, random sample. Unspecified distribution, which is interesting. Standard deviation is unknown, sample size is not large. Therefore, we're assuming there is an assumption that it is normally distributed, otherwise we can't do anything. Okay, so not equal to, two-tailed, from that it's a T, and there we go again. The critical value we would have to read off for our two-tailed test. 5% means we want 95% in the middle, which means 2.5% here, which means we're reading off 97.5% from the table. There are 10 items, so it's T9 that we're reading off as plus or minus 2.262. We write plus or minus because of the fact it's two-tailed. Check all the rest of it, please. Please show all your workings here and here. Write it out, substitute it in, write these down, substitute it in, give the correct answer. Compare the negative one with the negative one here. Ideally draw it. Okay? Those are the questions in the book if you've got it, and this is the mixed. So, is the sample large? Yes, then it's always a normal distribution. If not, then we may have to consider something else. If it's not normally distributed, can't do anything. If it is normally distributed, brilliant. Do we know the variance? No, then it's T. Yes, then it's Z. Another example. Please have a read, pause, have a go. The important facts this time. Random sample, normally distributed. We know that, and because the sample size is not large, it's definitely a Z test because we know the population standard deviation. Z test, there's the solution. So degrees of freedom aren't important. We go straight to our critical value. Here, it's negative because it's less than that we're looking at, and we get a negative answer here. Next one, another example. Please pause it and have a go. This time, standard deviation is unknown, sample size is large. Because the sample size is large, we invoke, or it's invoking, the central limit theorem applies, which means that our S squared is a good estimator of sigma squared, so we can use the Z test. So it's just a normal Z test. Final question, please pause it again. Important facts. Okay, we're testing less than, which means it's one-tailed, which means it's 5%. So in the question, random sample normally distributed. We don't know that, and the sample size is small, it's not large, therefore this is our t-test. You need to know the difference, you need to know when to apply it, it's down to you, that's the whole point. Critical value again then, 5%, be careful how you read it off. Draw a little diagram every time I would. Check that you get these values. If you don't, you're not getting it right. Okay? Email me. Okay, second part of the question then, this was quite a bit weird, the population, because was there any other dumping going on, so we had to take 0.3 off of everything. The mean obviously is affected by 0.3 coming off of it, the standard deviation isn't, because it's a linear scaling. Standard deviation isn't affecting by adding and subtracting, just multiplying and dividing. Okay, that's the other thing we had to do. If this to test that you know what you're doing, try and work out whether it's Z or t-test, all of these. Pause it and then I can expose the answers. Okay, so you needed to say whether it was Z or t-test and what the critical values were. And that's it. Okay, homework to be done for that lesson.